Despite a traffic pattern being one of the most basic flight maneuvers, it's one of the most important, and it's used for both VFR and IFR flying. This video is going to demonstrate how to enter a traffic pattern at a towered airport. First, let's briefly review the legs of a traffic pattern. Straight off the runway is known as the upwind leg. Then comes the crosswind leg, followed by the downwind leg, which parallels the runway in the opposite direction. Next, you have the base leg, and lastly, the final leg. When you're inbound to a towered airport, the most frequent pattern entry points are the downwind leg, the base leg, and the final leg. Remember that despite the standard traffic pattern direction being left traffic, and some runways published with a right-hand traffic pattern, at a towered airport, all published or expected traffic pattern directions are irrelevant, as the air traffic controller will instruct you which direction of pattern to fly. It's their airspace, and they may have a reason to have you on the opposite side of the published traffic pattern. Speaking of traffic pattern direction, remember that the direction of the traffic pattern is in reference to the direction of turns you're making while in the pattern. A common mistake for beginners is they think that left or right traffic corresponds to the side of the airport in which they are flying. However, that is incorrect. If you are instructed to make left traffic, you will be making left turns once established in the traffic pattern. Right traffic would be right turns once established in the traffic pattern. Now let's hop into the sim and demonstrate some traffic pattern entries with ATC. I've chosen San Luis Obispo Airport in California for these demonstrations. I've pre-coordinated with the control tower to have them issue us specific pattern entry instructions in order to demonstrate different commonly used pattern entries. In this first example, we're approaching San Luis Airport from the northeast. I'm going to call up the tower to land. San Luis Tower, Skyhawk 210 Pop Echo, 6 miles to the northeast, inbound to land with Zulu.
Skyhawk 210 Pop Echo, San Luis Tower, enter right down runway 29er.
And a right down runway 29er, Skyhawk 210 Pop Echo. The tower instructed us to make a right downwind for runway 29er. Looking back at the traffic pattern diagram, we'll be entering the downwind leg, which is the leg of the pattern which runs parallel to the runway in the opposite direction. The proper way to enter the downwind is on a 45-degree angle. It doesn't need to be a perfect 45-degree entry, but try and get as close as you can, as this will allow you to fit nicely in the traffic pattern, while also giving you an opportunity to see other traffic that may already be in the pattern as you approach the downwind leg. You want to approach the pattern at the traffic pattern altitude. Unless a specific traffic pattern altitude is published for the airport, pattern altitude should be 1,000 feet AGL above ground level for piston aircraft and 1,500 feet for turbine aircraft. The traffic pattern should be close enough to the runway where you can make the runway should you encounter an engine failure. This equates to roughly 1/2 to 1 mile from the landing runway. A good trick in the Cessna 172 or any aircraft with a strut is that the runway should be about halfway up the strut while you're on the downwind. This visual reference point should allow you to be right in that 1/2 to 1 mile area from the runway. Now don't get confused that we made a left turn to join the right downwind leg. Remember what I said before, once you're established in the traffic pattern, the direction of turn will correspond with the traffic pattern direction. The tower told us to enter a right downwind, but due to the 45-degree standard entry for the downwind, we're forced to make a slight left turn in order to join the traffic pattern. Once established in the pattern, it's all right turns from here on out unless the tower tells us otherwise. Notice how the runway is about halfway up the strut here. As I mentioned before, this is a good trick if you're at a high-wing aircraft with a strut to know if you're about the correct distance from the runway on the downwind. Also notice how we entered the traffic pattern at just about 1,203 feet. This happens to be the published traffic pattern altitude for San Luis Airport. Many airports won't have a published traffic pattern altitude or TPA, in which case we would use 1,000 feet AGL for the single-engine Cessna. You want to hold the traffic pattern altitude until you're abeam the numbers. That means when you're at a 90-degree angle from the runway numbers. Once you reach this point, you should begin a shallow descent and begin adding flaps if necessary. Remember, this is all assuming that the tower hasn't issued you any additional instructions. For example, if the tower tells us to extend our downwind leg, we would maintain our speed and altitude until further advised. Additionally, the tower may ask you to report something such as a midfield downwind, abeam the numbers, turning base, etc. If told to report one of these points, just call up when you're about to reach that point. If you're unable to get a word in on the radio at your reporting point, make the report as soon as there's an opening on the radio. The controller will understand that the radio was too busy for you to make the call at the correct time. As the runway is approximately at a 45-degree angle behind you, that's the time to turn your base leg. We'll start our right base leg turn here. Continue your shallow descent and continue to add flaps if necessary. Remember, you don't need a landing clearance to turn your base. This is all part of the standard traffic pattern.
November 210 Pop Echo, runway 29er, clear to land.
Clear to land, runway 29er, Skyhawk 210 Pop Echo. Now we've received our landing clearance. This is a critical clearance to obtain. However, without it, we should still continue flying the traffic pattern all the way up to the threshold of the runway. But if we get to the threshold of the runway and we're still without our landing clearance, we must go around. At this point, we're perpendicular to the runway. Timing your turn from base to final may take some practice and could vary based upon winds aloft, but over time, you'll get a good feel of when to begin your turn to final. As I enter the final leg, ideally I want to be at least 500 feet above ground level. This gives you a fighting chance to make the runway should you lose your engine. Now, as you recall, the tower cleared us to land during our base leg. However, if you get established on the final and you're still without a landing clearance, now would be the time to ask the tower. Something simple, such as Tower, verify Skyhawk 1 Pop Echo is cleared to land. We've repositioned the aircraft to be southwest of San Luis Airport. I'm going to call the tower inbound from this angle, and we'll see what kind of pattern entry they give us. San Luis Tower, Skyhawk 210 Pop Echo, 5 miles to the south, inbound to Lama, Zulu.
Skyhawk 210 Pop Echo, San Luis Tower, enter left base, runway 29er.
Left base, runway 29er, Skyhawk 210 Pop Echo. This time the tower instructed us to enter a left base runway 29er. Not a whole lot changes here compared to the downwind pattern entry that we received before, except for the fact that we'll be entering a left-hand traffic pattern as opposed to the right-hand pattern that we flew in the first example. Additionally, we'll be entering the pattern on the base leg. Therefore, we cut out the downwind leg entirely, and there's no 45-degree entry. Instead, we'll approach the pattern perpendicular to the runway and fly directly into that left base leg, ideally in the same spot in which we would have been had we flown the same pattern beginning with the downwind leg. As you enter the base leg, you should descend and add flaps as necessary, and then plan to turn final at least 500 feet above ground level. One thing to know about the base leg is that the tower may instruct you to enter or join the base leg with a specific mileage. For example, enter a 3-mile left base runway 29er. This typically means that the tower wants you to join the base leg, but further away from the airport than normal, likely due to sequencing with other traffic.
November 210 Pop Echo, runway 29er, clear to land.
Clear to land, runway 29er, Cessna 210 Pop Echo. In our final example here, we're starting southeast of the airport. Let's call inbound. San Luis Tower, Skyhawk 210 Pop Echo, 5 miles to the southeast, inbound to Lama, Zulu.
Skyhawk 210 Pop Echo, San Luis Tower, report 3-mile final, runway 29er.
Report 3-mile final, runway 29er, Skyhawk 210 Pop Echo. The tower instructed us to report a 3-mile final for runway 29er. This serves as a pattern entry instruction, and this type of instruction can be used for other legs of the pattern too. For example, the tower may instruct you to report a 3-mile right base for runway 29er. But in this current example, with reporting a 3-mile final for runway 29er, even though the tower didn't specifically tell us to enter or join the pattern on the final leg, we've met the Class Delta entry requirements. That is, we've established two-way radio communication. In other words, we called the tower, and they responded with our call sign. Because of this, we're permitted to enter the Class Delta airspace. Therefore, we can proceed to the requested reporting point of a 3-mile final for runway 29er. As a side note, entering the pattern on the final leg could also be known as a straight-in. The tower may instruct you to make straight-in for runway 29er, which is the same thing as entering the final leg. When we're instructed to enter the final leg, it's the simplest of all the pattern entries. You just fly straight in. You still may need to make a slight turn to line up with the runway, but try to do that sooner rather than later in order to approach the runway already on the final leg, that is, perfectly lined up with the runway. Begin your descent when you feel it's necessary. So now the question becomes, how do we know where that 3-mile reporting point is? Judging distance can be especially challenging in a flight simulator if you're new to flying on the computer, but it will get easier over time as you get used to everything. If you're struggling with your distances, consider putting the airport into your GPS before you call the tower so you have an exact distance readout at all times. Additionally, know that the tower doesn't need a report exactly at 3.0 miles. If you can do it because you have your GPS or a reporting point that you know is exactly 3 miles, terrific. But if you end up reporting at 2.7 or 3.2, the tower's not going to get on you for that. The biggest thing is that you're not reporting a 3-mile final when you're actually on a 1-mile final, or reporting a 3-mile final when you're still 5 miles away from the airport. These larger discrepancies are what can cause a lot of headache for the tower controller, and that's why you want to get pretty close, at least within about a half mile of your requested reporting point. Tower, Skyhawk 210 Pop Echo, 3-mile final, runway 29er.
Skyhawk 210 Pop Echo, runway 29er, clear to land.
Clear to land, runway 29er, Skyhawk 210 Pop Echo. In conclusion, the downwind, the base leg, and the final leg are the most commonly instructed points in which you will enter the traffic pattern at a towered airport. Now, while these are the most common, you always need to be ready for non-standard instruction, such as making a 270-degree turn, or even a full 360 if the tower needs it for spacing. Additionally, don't expect to always enter the traffic pattern on the side of the runway from which you approach. The tower may give you an instruction to cross overhead the airport, and then enter the downwind on the opposite side of the field. If this is the case, you can still enter the downwind on the 45-degree angle, but you'll just be doing so from the inside of the traffic pattern rather than the outside of the traffic pattern. For those unfamiliar, the air traffic control that you heard in the sim today was from the Pilot Edge Air Traffic Control Network for flight simulators. Pilot Edge offers live, real-time air traffic control. That's right, the air traffic controllers you heard today are real people who are working on the other side of the Pilot Edge network to bring you actual air traffic control for your simulator. If you're flying your flight simulator without air traffic control, or even if you're just using the default computer AI air traffic control, you need to check out Pilot Edge. Pilot Edge offers real-time air traffic control 15 hours a day, 7 days a week, guaranteed. Also, follow @PilotEdgeATC on social media for helpful tips and content.